Thank you. Your homework is going to be to make someone smile. If you take a picture of it, I will give you extra credit. Let's do our skip counting before we get into our goal for today. I have 2 reminders. First reminder is that once you finish your set with your partner, you stop and fold your hands so I know we're ready to go. And what to do if you mess up. If you mess up, I want you to start over. It's not a big deal. It's more important that we do the skip counting correctly than that we do it fast. Okay, ready? 2, 4, 6, 8, 10, 12, 14, 13, 18, 20, 22, 24. 1, 2, 3, go. 2, 4, 6, 8, 12, 14, 15, 16, 17, 18, 20, 22, 24. Dan and America are done. 14, 18, Ruby and RJ are done. 24. Gabriel and Luis are done. We are all done. All right, Unit 8. Day 3 of the life-changing Unit 8, how we can use graphs to solve problems in our communities. We're going to actually start with the information, the data that we used last year, or not last year, yesterday, about the crime rate in San Jose last year. So we're going to take one of the points from our graph from yesterday, that the crime rate in 2010 was 310 out of every 100,000 people, and we're going to talk about that specific crime rate. We want to talk about that one specifically because that's the one that's the most recent. 2010 is the most recent data that we have for crime rate. So that one's going to be kind of the most relevant for us right now. And some of us brought this up yesterday. There aren't 100,000 people in San Jose. And so I told you we would talk about this today. Remember that the crime rate is per 100,000 people. But there aren't 100,000 people in San Jose. So what we're going to do today is we're going to take that rate and see what happens to the number of crimes as we increase the number of people until we get to about 1 million. Because there's actually about 1 million people in San Jose. So go ahead and pick up your pencils. I'm going to be using pen. You should be using pencil like always. Ruby. There's extras right there. Let me know if there's not. Okay, crime rate. I'm going to say 300 crimes for every 100,000 people because 310 is a little bit messier to graph. So we're just going to simplify it by a little bit and round to 300. And we're going to put that information in a table. So we're going to take the population sample in this column. And what that means is it's a part of the population. So it's not the whole population necessarily. It's 100,000 out of 1 million or 200,000 out of 1 million. And that's going to be our X value. And then the number of crimes is going to be our Y value. So we already know that for 100,000 people, there are 300 crimes, or there were 300 crimes in San Jose in 2010. And that's a rate. So that means that if we add 100,000 people, we're also going to add 300 crimes. So for 200,000 people, there are 600 crimes. Okay, so Juan is filling that in on his guided notes. Josh is filling that in on his guided notes. America is filling that in on her guided notes. They've earned a positive point for the class. And every time we add 100,000 people, 300 crimes. Oh, I put this on the wrong line. That just means that I'm all ready for the next one. So when we add 100,000 people to 200,000, we get 300,000. When we add 300 to 600, we get 900. So there are no tricks on this worksheet. Every single time we're going to be adding 100,000 people, which means every single time we have to add 300 crimes.